All right. So with that, I would like to get to the demo part of this thing. So we have seen already the Salesforce demo. And maybe just to switch a little bit the order, maybe Carl, you can start with all P stuff this time.
Sure. I have a very small, can you hear me?
Yeah.
Okay. I have a very small presentation and then a live demo. So I'll share my screen. Share. Okay, you should see my screen now. So very quickly going over this presentation, just getting everybody up to speed. We're trying to combine optimization with a text and speech interface. Veselin already talked about why this is important. I also think this is the direction things are going in. They're emerging a lot of these textual or these spoken interfaces to typical platforms. And if you can do it good, I think it's really like also with the demo that Mihai gave about the playbooks, I think there's a lot of value there. It's very difficult because there's a lot of ambiguities. You can say the same rule in many different ways. We have almost no data to do it, and it needs to be quickly adaptable to new sensors. So before I talk about my proposed solution, I would like to, again, bring you up to speed with what I mean with a canonical representation. Here in green, we have 3 sentences which basically say the same thing. So for example, please SMS Veselin if the sun is shining in Ghent, tell him hello. All these kinds of things. Well, we can map this to a kind of English, pseudo-English sentence, so English with some parentheses, that really captures the semantics of this rule. And so if weather in Ghent equals sunny, then send SMS to Veselin, message hello. And our idea is actually to tackle this problem instead of trying to tackle the whole language space and translate that into Whaley rules. We'll try to translate natural language into this canonical language, and then we can easily parse this. And the idea is that that should be way more robust and extendable in the future. So the proposed solution, I made a couple of microservices. So we have a gateway, a database, then a machine learning model, GPT-3, and a parser. So text or speech comes in, and it gets sent to the database. And what this database does is it looks through the few examples we have of rules and tries to, with an algorithm, I'll not go into detail, tries to find some similar examples. So if you have 100 examples, it'll pull out the 10 most relevant. So for example, if you're talking about monitoring a patient's heart rate, it'll not pull out an example of turning the sprinklers on and off. So that's just a first filter. Then this gets passed to a model. And actually, so what this GPT-3 model is, to explain simply, you know, on your phone, you have like this autocorrect where you can take the next word. It's basically that on steroids, super big. So it just tries to predict the next word, the next word, the next word. And so the idea is you give it a bunch of these examples, and then you give it the sentence you want to translate into something canonical. And just by predicting the next word, it'll get there, hopefully. So then we translated a complex sentence into an easy sentence, and then we can send it to a parser, because it's very easy to parse sentences that always follow the same, you know, the same format.
Carl, is it fair to say that what digital twin does is to basically go straight to the kind of a parser because they create a canonical representation for the simplified UI?
Yes, so in the as much as I understand, in the digital twin, they just already have a very structured format where they input it. So then it's very easy to just make the rule out of it without any AI. The thing with speech is people will not always adhere to a structured format, or even if they talk in a structured format, the speech detection might lose a few words, so you can't assume that your input is structured. So that's why we need this database and this AI model to translate it and to get the structure back. And so that gets sent back. It requires user input on 2 things. And this is something I was really scared about, because we're trying to make a no-code or low-code interface here. We don't want a lot of user input. However, it's still impossible to just say, give me the temperature, to just know which temperature the user is talking about when you have 20 temperature sensors. So the user should give a few examples of his or her sensors, like how do I want these sensors to behave in natural language and in canonical language. And then the user or services or whatever needs to write one piece of code that helps create then the Waylay template. So I'll now talk a bit about this parser very quickly, and then I'll show the demo, just because it's still a bit of abstract. So imagine if you have a piece of a canonical sentence. So it's weather state in Ghent equals sunny and weather humidity in Ghent above 80. At one point, this needs to get parsed into a Waylay rule. Now, how do you do this? You use a kind of visitor pattern. It's also the same which Amazon Alexa uses. And that means at one point, your algorithm will see, well, I have an AND word. So you can see it in the get key phrases. It returns an AND, so it will match on this AND, and then it will run this visit function. And basically, if you look towards this pseudocode, you can see it does something very simple. It parses the string. It takes the condition to the left and the condition to the right. It processes them, so it also visits them. And then once it has those two things, for example, these are now Waylay sensors initiated, it can say, okay, now create an AND relation between those two things. So that's the way how you can translate then that canonical language in the Waylay JSON, the template JSON, with minimal amounts of code. So I basically, it's kind of a Python SDK actually for creating rules. And that's how that works, but I'll show it in a bit more detail later. Now I will show you a demo. You should be able to see my new screen now, the application.
Yep.
I thought about two ways of doing this demo. I can either show the full potential right away, or I can kind of walk you guys through it and try to make it interactive and together explore what this technology is capable for. So first, let's see which rules are in the database. There are only 4 rules in the database. So the entire application now is resting on only 4 examples of what it should be doing. And so, for example, here I have the weather in Ghent is sunny, send Vizellen and SMS with message want to go for running. Here, the canonical version, which we can easily parse. If the weather is not snowing, blah, 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 send something, only do this when it is raining. Okay. So let's input a written rule now. So maybe ask Vizellen what's up via SMS if it is snowing in Paris. So maybe reflect on this. So in the previous demo Vizellen made about the parsing, this would already fail because there's no key message here. You're saying ask Vizellen what's up. So it's very difficult to parse a message out of that. But I'm going to submit it and hopefully it'll work. Okay, and it works. So what is our output? This is really not that important for you guys. That's just the actual input to the model. So if you see, we here have our Ask Vizellen question. And these are the database examples that our model pulled up and sent with that example to our model. Then we have here the canonical. So the if weather state in Paris equals snowing, then send SMS to Vizellen. And for example, it knows to translate what's up in a question. And then because this sentence is a canonical sentence, our parser can turn it into a JSON, in the JSON. So get weather with the open weather key, the Twilio SMS with the what's up to Vizellen, and then a trigger based on the snowing state of get current weather to the SMS. So now it's time to have some fun with this. So I think if it is snowing in Moscow, tell Gilles a joke via SMS. It's running. Yeah, so the problem now is it outputted a too long joke, which my model can't handle. It says something like a snowman walks into a bar and says, I like a beer. Okay, it's not that funny. But the thing is, what I would like to illustrate is sometimes people just, you don't have to literally input what you expect. The model can make assumptions and has a lot of prior knowledge into it. So maybe tell Gilles a short joke via SMS. It's parsing, it's parsing, it's parsing. Did I press the submit? Okay, it's still outputting the same joke. Okay, it's not very funny, but maybe let's try to do some more complex things. So if the weather in the capital of Belgium is raining, I don't know, send Kyle a wake up message. Okay, so these rules do not really make sense, but it's to illustrate the technology. And here you see that it even correctly translates the capital to Belgium to Brussels. And that's really not any processing I initiated. So even based on, and that's really the amazing thing here for me, you're only giving 4 data points. Typically in machine learning, it's completely worthless. You don't even try if you have less than 1,000 data points. But just based on smart use of the prior knowledge of this model, with 4 data points, we can do things like, I say the capital of Belgium, but it knows it needs a city name. So it just translates that to Brussels because it knows the capital of Belgium is Brussels. For example, let's say I would like to send a message via mail. There are absolutely no examples of email use in the database. So let's see how it will handle it. So I'm hearing echo. Brent, could you mute yourself? No problem. So it errors, but it actually does something very smart. It uses the same format. It says send email to somebody with a message. The problem is there is no email sensor yet in the backend. So maybe I'll now walk you through how you can add a new sensor and get this new capability. Here, my screen. So I have here this, I downloaded the JSON for the mandrel mail sensor. And I've written some code to support the email sensor. So basically, the only thing that this code does is, once you get this string, say how to parse the string and how to interpret these words. And then I also need to register it. That's just because my code is not optimal. Now I'll build again, and now we'll see if the mail sensor will work. Oh, I need to import this also. Okay. This should not take too long. But so basically the idea is it's somewhat a drawback that you still have to write a bit of code. But if you can really define what type of sensors need to be accessible over voice, for example, what kind of sensors and rules a factory worker will be using, for example, in the production line, you can implement these in advance and then supply a bit of rules, and then you'll know it'll work quite robustly. And I think you'd rather have a robust working on a limited set of sensors than shaky working in general. So where is my demo here? Let's refresh this. Let's hope that it now knows how to work with email. Yes. So the sentence, send email to Kyle, message wake up. It now processed it. It used the mandrel mail sensor. But again, there's not a single example about using mails in the database. So I can go on and on. I think there are some really, I think I have, for example, so I'll do something like send Gilles a wake up message.
You have a typo, but maybe it's not a bad.
No, it's no problem. I don't think it'll be a problem. Do this only on Monday. So Monday, I don't know which sensor works with Monday. And I also have no examples of it, but let's just see how it handles it. Okay, so it just dreams up if day of week equals Monday, then, and also the typo didn't matter, send to Gilles message wake up. So basically the only thing I need to do now is in my code, link the day of week to a day of week sensor, and I'm good to go. So let's add some noise. Okay, this would be very hard to parse without any smart things going on. And it did something here. It starts to fail. So it says it removes the noise, but it dreams of it starts talking about if the weather in Paris is also rain. So this is the drawback of a live demo, because it didn't happen 10 minutes ago, but okay, it's work in progress. Maybe if I fix this typo, I don't think so. No, okay. So here it's not performing well, which is to be expected, because you would recommend your typical inputs to be a bit cleaner. I think, I don't know how much time you have left. I can show a lot of cool capabilities that it still has, and with other sensors.
Yeah,
but
sure, go ahead. Because again, we'll record it, and I mean, because this is one of your last days, so maybe it's not bad to just go over that. Just go ahead.
Sure, I'll maybe just try the speech input first. So the speech input, you sometimes need to try it a couple of times. There are ways how you can guide it. So I think in further research, you can really make the speech work better, but now it's really just out of the box. So if the weather in Ghent is nice, tell David hello via SMS. Okay, so I have a couple of alternatives, but this one translated pretty good. Submit. Okay, yeah, it can't handle the word nice. Yeah, it needs to be sunny.
Sunny, yeah.
Yeah. Well, if you give actually one example of nice and sunny, it starts translating nice into sunny. But okay.
Indeed.
If the weather in Ghent is sunny, send David a hello message via SMS. Sunny, David here, okay. It dropped the send, but I don't think that will be a problem. Weather state in Ghent is sunny. Okay, didn't translate well. If the weather in Ghent is sunny, then send David a hello message via SMS. Sunny, then send. Okay, submit. I don't know why this is not parsing, because this canonical is good.
Yeah.
But okay, I was making some last minute changes to the code. But anyway, so the most difficult part went well, and that is translating it into something canonical. And you can start going crazy. So you can add, let's maybe add something more complex. Maybe here I have a rule pre-written, so here I can input rules to the system. So let's maybe add something with a between statement. So this is again how I expect a natural language to be, and this is how I just wanted to represent it. So I'll add this rule, and maybe let's also add something about humidity. Add a rule. So again, I'd like to stress that this entire technology is now leaning on 5 data points, which is nothing. So if the humidity in the capital of France, I don't know if it will work with the exceed. I don't know. Let's see. 80%. And the weather in Paris. Okay. Paris is sunny. Tell this to Mihai. Let's see. Let's hope. Okay.
Wow.
So it says if weather humidity in Paris is above 80 and weather state in Paris equals sunny, then send SMS to Mihai. And I said, tell this to Mihai. It said the humidity is above 80%. So your input is really quite bad. Yeah, like this is not a good input to describe exactly how the rule should work, but it knows it needs a message, and it takes some basic knowledge about language to just make an informative message. So I personally think that that's quite impressive. And so you can imagine that now you input this in the Whaley, you get it back, and then you can, you know, rewrite the message or add something else. Maybe make it an OR statement. There's no OR statements in the database. Let's see if it works. Okay, it basically no. Yeah, sure.
If you remove Paris, will it know you still refer to Paris?
Good question. I hope so. Yes.
Well,
maybe something else like if the weather is sunny, send Kyle a message about unicorns, the weather in Ghent. This would be really difficult to parse with normal things, but it knows, okay, weather is sunny. Yeah, I'm talking about the weather in Ghent. So let's do the weather in San Francisco. Let's hope it now changes it to San Francisco. Okay. So you can really use free flowing language. And I think this is really the best approach for, again, based on almost no data. 5 data is the same as 0 data in machine learning. To have something that can kind of start interpreting humans. And the interesting thing is that this is really built upon a general technology, which I know is getting developed further by companies like OpenAI, Google, and Facebook. So you can just, I think you can just copy paste this technique to the newest model every time. Like, we're not even hosting the model. We're not even retraining the model. We're just pinging an API. So I think this is the most robust thing you can have. And also it said unicorns are real. Okay, enough playing. If anybody has a request, but else I'll wrap up my demo.
yeah, thanks, Carl. I suggest, I mean, that okay, of course we're gonna have a follow-up meetings and, you know, to describe the technology and maybe record a little bit more of this. But I mean, I have to say, it's very impressive what you've done in 5 weeks. Absolutely impressive. It's just, I didn't know even that it was possible to do these things, to be honest.
Well, it's not possible for long. So it wasn't possible a year ago, I would say. This is just to give maybe a bit of history. Typically in machine learning, the first thing people did in machine learning way before I even knew about computers was engineer features, make better features, and then design an algorithm on these features. Then people were like, okay, let the algorithm make features. We'll just gather more data. Then recently they said, well, let's just pre-train a model on a lot of data, then inject a little bit of our data and let it work. And now with these models, because this model, this costs 12 million to train. So that's why we're not training it. That's why a company has trained it. You just have a model so big, generally trained, that has a lot of these capabilities, and you just ask it questions. So this is basically just text we input, and then we ask it, predict the next word, predict the next word, predict the next word. And this coherent thing comes out, which we can parse.
Yeah, amazing. Thanks, Carl. Thanks, really cool. Yeah. Cool. All right. So
Carl, I have a question.
Sure.
Is
There are some
there
questions.
and yeah, is there anything specific in or where is the language encoded? If you would have pre-filled your rules actually with Dutch sentences, would it have worked?
Well, so where is it encoded? The language, the model is just trained on English. However, it is they're working on making multilingual models out of this. So trained on a lot of languages at the same time. And actually these models, they have actually just read so much of the internet that also some Dutch and some French sentences crept in. So if you ask it, please translate the following sentence to Dutch, and you give it an English sentence, sometimes it just starts outputting the Dutch sentence, while it was not specifically trained to do that. But it mostly now works on Dutch because most of the internet is on Dutch.
Just out of curiosity, have you tried a Dutch sentence to see what would come out of it?
I have no clue. I don't even know how to.
Or maybe just say okay in Dutch, like okay.
I'm trying it now,
here.
but my wacht, hè?
Yeah.
It's
okay.
maybe working actually.
Okay, can you share the screen to share your excitement or disappointment?
Yes,
do that?
yes, you will see my excitement or disappointment live, front
Yes.
row.
Yeah, okay. That's great.
I don't think this should work. Again, it has read a lot of data. So als het weer mooi is in Parijs, stuur Zillen een bericht via SMS, submit. Fuck me.
Shit, it worked.
If weather stated in Paris equals sunny, then send SMS to Velen message the weather is
Wow.
sunny.
Yeah.
Mooi is in Parijs en de vochtigheid boven 80 is. Fuck.
Wow.
Yeah, it does it. So yeah, the thing is, they just basically downloaded the entire internet and just trained it on it. So it has also a lot of Dutch. This is also the first time I tried this, but again, to show how powerful this technique is, and maybe also how scary. I don't know. You decide.
We will make it scary, no worry.
It's scary, eh?